Hi, I'm Ashley Rice.
And I'm Melinda Rose, and this is Light Matters for June 5th, 2013.
On this week's show, a light-controlled gel could help robots go soft, the first privately owned telescope readies for space, and a graphene photosensor could eliminate the need for camera flashes.
Inspired by the way plants grow towards light sources, bioengineers at UC Berkeley created a hydrogel that can be manipulated by light. The gel could have applications in drug delivery and tissue engineering, as well as the emerging field of soft robotics. Synthetic elastic proteins were combined with graphene sheets, which generate heat when exposed to near-infrared light. The materials together form a nanocomposite polymer or hydrogel that can mimic the way plant cells expand and contract in response to light, only in a much more precisely controlled way. The nanocomposites exhibited rapid and tunable motions controlled by light position, intensity, and path, including finger-like flexing and crawling. The work was published in Nanoletters.
In an experiment its backers say will democratize access to space exploration, the first privately sponsored telescope is set to launch to the moon in 2015. The International Lunar Observatory, or ilo-x, will pioneer an era of global space research, enabling anyone with an internet connection to access images from the surface of the moon. It was designed and is being built by Moon Express of Silicon Valley for the International Lunar Observatory Association, which is also tasked with delivering it to the moon in 2015. The ilo-x's primary goal is to expand human understanding of the galaxy and the cosmos through observation from the moon. Its images will be accessible to educators, researchers, and the general public. About the size of a shoebox with a mass of about 2 kilograms, the ilo-x uses innovative optical technology in combination with advanced software and micro-miniaturized electronics to deliver deep space images of objects inside and outside our Milky Way galaxy. Flight test hardware for the telescope was unveiled at the ILOA Galaxy Forum Canada 2013, held May 25th in Vancouver. The ilo-x is a precursor to the permanent installation of a larger, more powerful International Lunar Observatory at the moon's south pole.
A broad-spectrum photodetector developed using pure graphene is 1,000 times more light-sensitive than current sensors and able to detect wavelengths from the visible to the mid-infrared, making it suitable for all types of cameras. The new image sensor was invented at Nanyang Technological University in Singapore. Not only is it ultra-light sensitive, but it also uses 10 times less energy than today's cameras because it operates at lower voltages. Graphene is known to have a high electrical conductivity, among other properties such as durability and flexibility. When mass-produced, graphene sensors are estimated to cost at least 5 times less than conventional ones. Assistant Professor Wang Quiji said his breakthrough, which took 2 years to achieve, was in fabricating a graphene sheet into novel nanostructures. These structures trap light-generated electron particles for a much longer time, resulting in a much stronger electric signal. Such signals can then be processed into an image, such as a photograph captured by a digital camera, even in dim light. The innovation, which can be implemented using standard CMOS chip processing, could impact not only the consumer imaging industry, but also satellite imaging and communications. Wang filed for a patent through the university, and his next step is to work with industry collaborators to develop it into a commercial product. The results were published in Nature Communications.
That's it for this edition of Light Matters, the Photonics Industry's only weekly newscast. As always, you can write to us with your comments or questions at lightmatters@photonics.com.
Thanks for watching, and I'll see you next week from Clio 2013 in San Jose.